Hello everybody, welcome to the final project. So you've made it through the lectures and now we actually get to play around with machine learning. So this is going to be fun, and it's also going to show us how to actually use some of the things we've been learning in the lectures. So during this final project, we're going to build a deep neural network and use reinforcement learning to solve a cart and pole balancing problem that uses the OpenAI Gym. OpenAI Gym is a toolkit for developing and comparing reinforcement learning algorithms that was built by OpenAI, a nonprofit artificial intelligence research company founded by Elon Musk and Sam Altman, which is, of course, OpenAI right here. OpenAI is really easy to install. What we're going to do to install OpenAI is use Git. So if you don't have Git, you're going to have to follow the installation instructions online here. Thankfully, if you're on Windows, it's really easy. You simply click this link. Mac and Linux, just as easy as well, a link or an apt-get. So once you have installed Git, we'll be able to get going with OpenAI. So OpenAI just provides us with, or OpenAI Gym specifically, provides us with different environments that we can do reinforcement learning in. So these environments could be Atari games, they could be different little scenarios. A lot of the environments require additional dependencies, so we're going to use one of the simpler ones. But if you want to play around with, for example, the Atari games, please do, because OpenAI is a great source and a great way to compare different networks and the performance of different artificial intelligent networks. So let's go ahead and get started. What you're going to do is you're going to open up your command prompt. I'm going to run it as an administrator. Sometimes the download permissions are a little bit different depending on if you're an administrator or not. And the first thing I'm going to do is go to the folder where I have been making these projects. So you see we have some of the past projects here for different units. This is going to be the final project, OpenAI. So what we're going to get to install OpenAI is a simple git command, and if git's shown in your environment variables, which it should be if you follow the installation, you can simply type git clone, and here is the link, OpenAI/gym. So let's go ahead and click enter there. And so what this does is it just downloads a zip file and unpacks it into whichever directory you're in. So you see now, I now have a folder over here called Gym. So if we move into that folder, we can go here. All that is a simple file with all of the necessary scripts and stuff to run OpenAI Gym environments, as well as download and install instructions. Like requirements.txt is going to tell pip, which we'll use to unpack this, which Python libraries it depends on. And so to do that, we're going to use pip, which should already be on your computer if you've followed along with the other projects. If not, it's really easy to get. And we're just going to do a minimal installation and a period to show that we want to install in the current folder and directory. So let's go ahead and click enter and do that. And this will go. So like I already have NumPy installed, it's just going to skip through those, and that was really quick. Successfully installed Gym. So now that we have that, we can go ahead and get into our Jupyter Notebook. So I'm going to make this in the tutorial folder, and again, just type Jupyter Notebook, and that'll open that up. It's really easy if Jupyter is in your Python path variables, or in your general path variables. So that's going, and here we go, opens up. All right, and so what I'm going to do, I'm going to start a new project. I'm just going to use the default Python, which should be Python 2.7, but we can check that. So what we're going to do is import sys, because we want to check and make sure that we're all using the same Python versions. I'll do sys.version. So this is a good thing to do at first. So it is Python 2.7. And it's the Windows 64-bit version. So now that we have that, let's move on to importing our OpenAI Gym. Let's make sure we have this. And what we're going to do is we're going to do a print gym.version. We're also going to do import Keras. So if you don't have Keras installed, you're going to have to do that. But thankfully, it's really easy using the command prompt. Once again, you can simply type conda install Keras, and this is going to actually use the Theano backend, and you can install that with conda or pip as well. So let's do this, and we're going to do a print keras.version. Make sure we're all on the same page. So let's run this with Shift Enter once again. So sweet, it imported Gym version 0.93, and then this is importing Keras successfully, and it says it's using the Theano backend. It's very nice that it tells us version 2. If you want to change which backend it's using, you can go into your .keras folder, wherever this was saved, usually in your user directory. And this file right here, if we open it with a notepad or WordPad, it'll specify the backend. So you can change some of the configuration settings right here in this file. This could be TensorFlow or Theano. Those are your two options with Keras. For this project, we're going to use Theano though, so if you want the code to run, this is what you're going to have. But again, you only have to go in and edit that if this doesn't say Theano here. All right, let's import some of the other libraries that we're going to need to use. These should be a part of the Python standard library, so you shouldn't have to download or install any of them, except for maybe NumPy. No, that's standard. So these should work, but if not, again, you can get them with pip or conda. So let's go ahead and do Shift Enter, make sure this works, and yes, everything imported okay. All right, so let's get into actually building the OpenAI Gym environment so we can play around with it and kind of understand what we're working with here. So first things first, we already did the import Gym, so we don't need to do that again, but we do need to define our environment. We can do that simply using Gym.make. And so we're going to use the cart pole option, because this is one of the environments that comes in the minimal installation. It doesn't require any additional dependencies, plus it's a good project for us to solve. So we're going to use that one. And then what we can do here is simply define a example scenario that runs the environment. It's not going to have any machine learning in it yet, but it will demonstrate what the network's going to do. So we're going to run a certain number of episodes, and that number is going to be 20. So if we run 20 episodes, we're going to have observations, and this is going to be the environment, whatever state the environment is, or like if we were playing a board game, you know, with the position of the chips, this is going to be the current state of the environment. And we're going to reset that each time because we want to start from the beginning. So we're going to go for 100 time steps each time. And we can do environment render. Let's go ahead and print the observation, just so we know what the state is and we can see what that looks like. We're also going to have an action, which is what we're going to do based off that state. For this example, we're just going to sample one. So we'll take a sample out of all of the possible actions in the action space. Observation then, and reward, done status, and info is going to be equal to our environment step based off that action. And we can add an if done here. So if done, we're going to break and we're going to print episode finished after. We'll add this in here, time steps. We do the dot format to substitute a variable into the string. And then break, as we mentioned. So let's go ahead and run this and see if we can actually generate that environment. Invalid syntax. Of course, I put an equal. I don't want that. I want an in. Here we go. So made an environment, and here's actually our cart pole. So if you see, this is just balancing on top of this pole. It's stopping it every time after a 100, but that's okay. So here we're also printing out our observations. So the state of our environment has 4 different variables. And this again is printing episode finished. Let's take this off for a second, and let's also make this a little bit longer so we can see it not cut off right away. So let's start this again. Well, we're getting some balancing. This is based off the done status, actually. So it's going to stop every time that it gets done, so we can't have this swing around. Let me take this off and see if it will just go. So there it was kind of swinging around. Let's try that one more time. Yeah, there we go. So that is our environment. And what we want to do is we want to teach a network to apply in either a force to the left or to the right so that it balances that pull on top of the little cart. So that would be pretty hard to balance. You know, balancing a pull on its end is not easy to do in real life, but I think that we can train a reinforcement learning algorithm to do this, and that is in fact the case. Let's explore some other parts of our observations and actions. So what I want to do is I want to do a print environment.action space, so I know all the possible actions, and I want to do a print environment.observation space. So these are going to tell us our possible action space, or our possible actions, and all our possible observations. So this is telling us the types. And what this is saying is the discrete space allows a fixed range of non-negative numbers. And in this case, the valid actions are going to be either 0 or 1. And the box space represents an n-dimensional box. And valid observations for this case will be an array of 4 numbers. So we can also check the box's bounds. So let's go ahead and do that. And we'll do a print environment.observation space. So our maxes, high, and then let's print the lows as well. So here we go. This is basically infinity here, positive and negative infinity, and this is essentially 0. So this is the possible ranges of the observations. These are probably specifying things like location of the cart, location of the pole, and then of course this is just acting under the force of gravity. So our possible actions, we have 2 actions, 0 or 1. One's going to be a force to the left, probably 0. One's going to be a force to the right, probably 1. Although we could play around with that and figure out which one was which for sure. We're going to have an observation which gets returned as a result of that action, which is going to be defined by these 4 numbers. So that's that. We have all of the libraries we need imported. We have Keras set up with the Theano background, and we also have an OpenAI gym that's going to spin around and have a pole on top of that cart that we can try to balance. So this is going to be fun, but we will start building our model in the next video. So thanks for getting this all set up. We can dive into our network next. Keep listening.